Okay, good evening, ladies and gentlemen, and welcome to this Monday live session on Lean Six Sigma. And the live session's objective is to understand the concepts in better, in the depth, and how to apply them practically, learning that. Okay, so today we are going to discuss a topic which is interesting topic about something called stability as well as the process capability, which is the control limits and the specification limits. Okay, so it's much better than before, but a lot of cough and weakness is still there. Okay, in fact, I had been to last week. I was traveling to my client's place, and it was a 4-day continuous session. But unfortunately, I had to abort that session after a couple of days and come back to Mumbai because of the ill health. But now I'm doing well. Thank you very much, Maheshji. Okay, chaliye, so let's jump into the topic straight away, and let me quickly go to my whiteboard. So, everybody must be aware about um, control limits. Everybody, just type yes if you are aware of control limits. Just give me yes in the chat box quickly. चलो हम लोग टॉपिक में directly enter कर रहे हैं. So what is control limit? Just give me yes if you are aware of it. Yeah. So I got 1 yes, 2 yes. Okay, everybody. If you're aware of control limits, just type yes in the chat box. If you're not aware, just type no in the chat box. Very simple. Yeah, go ahead. Okay, Shailesh ji says no. Rahul ji says yes. Okay, Pallavi says no. Fantastic. So we have people who don't know about control limits. So let me just quickly touch upon this first. Okay. Now, after World War World War First, after World War First, this was a period in 1930s. That's where one of the very important development happened in the field of quality. And that development was statistical process control, SPC, using statistics to control the process. See the name itself, statistical process control, statistical process control. So using statistical data, okay, to control the process is what statistical process control means. And the name of the father of this was Walter Shewhart. Just make a note of this. Okay. He is one of the biggest contributor in this SPC. Okay. And whatever we are learning about control charts, CPCPK and all those stuff is because of Walter Shewhart. Okay. Now, according to Walter Shewhart, he basically investigated, did research and development on lot of data and a lot of processes, and he concluded and he put forth his findings in front of the statisticians and the scientists and engineers community, and they agreed upon his formula. That his formula was any process, okay, which runs within +3 and -3 standard deviation. So let's say this is the process. Okay. And this is the average of the process, X bar. And this is upper control limit. And this is lower control limit. These are two lines. So what is the formula? He said upper control is X bar +3 standard deviation. And lower control limit formula is X bar -3 standard deviation. So any process which flows within this band, does not go beyond this band, is said to be a stable process. The word what is used is stable, not capable. Try to understand this. Okay. So these two bands, upper limit and the lower limit, are called as control limits. So Walter Sheward says after a lot of R&D expenditure, etc., etc., etc. Okay. So you get +3 and -3 standard deviation. Any process which flows through this is called as a stable process. Stable meaning kind of predictable behavior of the process. You can predict the behavior of the process. If there is a variation within this. Now, what is this data I have plotted? It can be anything. It can be your daily sales. It can be daily production. It can be, the attendance. It can be anything. Whatever process you are having, if you want to plot the performance of the process, on the time scale, on the, on the x-axis, there should be time. There should be some time, meaning it should be daily, shift-wise, weekly, monthly. It is your call. Okay. So you collect the data and plot it in the graph, make a average line, which is X bar. So let me write here. X bar is nothing but average. Okay, simple average line. And then you plot it. So for example, everyday production, if somebody is plotting, okay, one day they made 100 units, other day 120, then 130, then 90, then 80, then 150. So this way, the flow will be there, the variation will be there, but then they will calculate the average, which will be the center line, and then upper and lower control will be calculated with 3 standard deviation on each side of average. Okay. So any process, so the statement, let me repeat the statement once again. Any process which flows within +3 and -3 standard deviation band is called a stable process. Everybody, are you clear about these control limits now? Just give me yes or no in the chat box. So these are called as control limits by Walter Sheward. We are going to go deeper today into this concept. Just try to understand this, okay? Try to correlate with your own process. That's the best thing what you need to do. Okay? Whatever concepts are being discussed here, please try to connect it with your own example. Clear? Yes? Yeah, I'll repeat again. Now, if you collect the data, okay, let's take an example of, type in the chat box. Please discuss or please think about any continuous data from your process, which you can monitor on a continuous scale, any data, even discrete data, low and high limit. Is this same as histogram, low and high limit? That's good question, Mahesh. That is the topic we are going to discuss today. What is the difference between this and the limits we use in histogram? Okay. Yeah, flange width dimension in wheel manufacturing. Very good. Tablet specification. Okay. Super. Not specification, actual. Maybe it is your assay, for example. Tablet ka assay, if you're having that, or tablet ka dimensions. So you are measuring that. You take a sample, and now every batch-wise assay you are plotting. That is your process. Sorry. Bore diameter, yes. So you are taking samples and you are plotting the bore diameters on this. Okay. Net content, yes, very good. So whatever is your process, everybody, can you connect now? You just have to select one data point which you monitor every day, every shift. Okay. Fan blade height, very nice, super. So now imagine you are monitoring that. Okay. Now, once you plot it, okay, what I would highly recommend you, do you remember during our school days, we used to draw the graph manually, graph paper ke upar, yes? During schools and colleges, we used to do the graphs. Do you remember everybody? Just give me yes in the chat box. Graph paper pe hum log plot karte the graph ko, upar niche, and that. So the same thing which is we are plotting. Imagine this is a graph, okay? Then you have to plot a average line in the center. You have to plot an average line, and after average, upper and lower control limits also you can plot. Okay. In earlier stages, we used to do it manually in the training programs. In the physical training programs, we used to do it manually. We used to distribute graph papers and used to ask people to plot the graph manually. Once your concepts are clear, then you can easily do that. Okay, very good. So once you plot it, then you draw a average line in the center, which is x bar. Then for the same data, you calculate standard deviation. What is the formula for standard deviation? So formula for standard deviation is this: summation of xi minus x bar raised to square divided by n. Actually, it should be n minus 1, but let's take it to n. Summation of xi minus x bar square divided by n. Xi meaning what? Xi is an individual, actual individual data point. Xi is individual data point. And what is x bar is average, which we know that, right? N is equal to number of data points. Number of data. So once we collect the data, we calculate the sigma. Now, see, we have software with us, so we don't have to do it manually, right? But we should understand from where it is calculated, correct? So first average will be calculated, then standard deviation will be calculated from x bar plus 3 standard deviation and minus 3 standard deviation. For example, let's take a data where x bar is 40 and standard deviation is equal to, let's say, 2. Can you calculate upper control and lower control limit with the formula of UCL and LCL? X bar is 40. Imagine x bar is 40 and standard deviation sigma is 2. Can you quickly calculate your upper and lower control limits, please? And type in the chat box. Everybody should calculate it, okay? The formula is here. This is a formula. This is a formula for upper control limit. And this is formula for lower control limit. Yeah, let's calculate it first. We are talking about which is 46 UCL. 46.34 कैसे आ गया? 2 only, 2. 40 is the x bar. Sigma is 2. That's it. So sigma मैंने already दे दिया. You no need to calculate its standard deviation again. Yeah, 46 will be upper control limit and 34 will be lower control limit. So here x bar is what? 40, right? Plus 3 into standard deviation is 2, right? So this is 46. And lower control limit is what? X bar is 40 minus 3 into 2. So which is 6. So 40 minus 6 is equal to 34. So upper control is 46 and lower control is 34. If the process is within 46 and 34, then the process is a stable process. And these two lines are called control limits. Now, is it clear, everybody? With this simple example of with calculation with formula. Just give me yes in the chat box. Yes? Very good. Now, the next question comes, which lot of people ask the question about why only plus 3 and minus 3 only. Why not plus 2 and minus 2? Why not plus 5 minus 5 standard deviation? Okay. Just for our understanding, just listen to this explanation and forget about it. Okay. At plus 3 and minus 3 standard deviation band, okay, just listen to me very carefully. I do not want to open this box of discussion, okay, with this error. I will take a separate session about it, but make a note of it, okay? At +3 and -3 standard deviation, write this down. Alpha and beta error gets balanced out. Write this down. थोड़ा heavy statistical है, but just for your information, write it and keep it as it is. Okay, we'll cover it some other time. At +3 and -3 standard deviation, alpha errors and beta errors balances out very well. That's what the research of Walter Shewart. That's why he specifically said that x bar +3 standard deviation and x bar -3 standard deviation, we should keep our control limits. Yahan tak clear hai everybody with me? Even if you have not understood what is alpha error and what is beta error, etc., it's okay. It's a part of hypothesis testing. If you even check the analyze phase of green belt, you can find slight definition of alpha and beta error. We'll cover that later. Control limit clear? Just give me yes in the chat box. Everybody's clear about control limit? Just give me yes. Can you connect with your own process? That is most important stuff. Whenever we are learning a concept, try to connect. Okay, where can I use this in my process? Always ask this question. Yes, you can connect. Very good. Now, sorry because of my bad throat today. Yeah. Now, coming back to specification limit. So this was control limit. Now, who has set the limit now? Who has given the limit? The process itself has decided, because according to the variation, the x bar and sigma is calculated, right? So nobody else has decided, only process itself has decided the control limits. Have you understood this question, understood this point? Upper control and lower control, because x bar is what? The average of the process data. Sigma is what is calculated from the process data. So x bar and sigma both are calculated, which are the main component of the formula. Both are depending on the data from the process. So who decides control limits is the process itself. Have you understood this statement? Clear? Have you understood this? Just give me yes in the chat box. Everybody, give me yes or no in the chat box. Upper control and lower control, UCL and LCL, are decided by the process itself. No one else is deciding this. However, whatever data is coming from the process, that itself is deciding UCL and LCL. Clear? Okay, very good. Now, let me wipe this off. Hope you guys are taking the notes along with me. Now, let me speak about control, about specification limits. Okay, let me just. How can मतलब समझा नहीं मैं क्वेश्चन सदा नहीं, थोड़ा सा क्वेश्चन डिटेल में पूछिए so that I can answer. Now imagine let's say x bar +3 -3 स्टैंडर्ड डिविएशन ना, तो फॉर्मूला ये है ना, UCL एंड LCL का फॉर्मूला जो दिया हम लोगों ने, x बार प्लस and x bar -3 sigma. This decides the limit. That's it. Okay, yeah, good. Now, now coming back to the second limit, what we were discussing, and that limit was specification limit. Now, who decides specification limit? It's the customer. Customer says, I want the cup of tea within, let's say, 60 degrees centigrade and 80 degrees centigrade. So 60 degree becomes lower specification limit. Specification limit, not control limit. And 80 degree becomes upper specification limit. And who decides it? Customer decides it. Customer wants that I want the cup of tea within 60 and 80. Below 60, it will be too cold. Above 80, it will be too hot for me to consume. So I want within 60 and 80. Why do we have this kind of a band given? Why do we have a limit given? And why not only one point? For example, why don't customers say that I only want the cup of tea at 70 degrees centigrade? Why can't customers say that? Type in the chat box. According to you, what is the reason? Is the customer very generous? Is he giving us some kind of a, the leeway? Why not 1 point, and why there's a limit? Very good, very good. Yeah, type, everybody think about it and give me the answer. Give me the answer. Why we always have a limit, and why not only 1 point target? That's it. Super, super. Now understand this. Very good. Good answers. Because of the variation of the process, which is the universal truth. I always say this. Variation is a nature of nature. You cannot take variation out of the process. Right? So this variation always gets reflected everywhere. That's why customer gives us a band, that whatever variation, you make sure your variation is limited. Okay, between these 20 degrees centigrade. Whatever cup of tea you are serving to me, it should be between this point and this point. Okay. Now, who decides it? Customer decides it. According to their requirement, they tell us their requirement, and that's what is specification limit. Now type in the chat box, in your process, give me 1 or 2 example of specification limits you have set, meaning customer has set for you. Give me your own process examples of specification limits. Connect with your own example, connect with your own product or service. Service में भी होता है specification limit. Yes, we all know that. We sign SLA, service level agreement. There also specification limit exists. Correct? Yeah, type in the chat box. Give me a couple of examples, 1 or 2 examples. 95% quality, exactly. It's a specification limit. So it's a lower specification limit. So minimum you keep 95%. Above you can go, 100% as well. Holding temperature of milk for pasteurizer, 90 to 95 degree. Fantastic. So 90 is a lower specification, 95 is the higher upper specification limit. Day of completion, 20 to 30 degrees. So 20 is the lower specification, 30 is the higher specification. Run out spec 0.80 mm to 1 mm. Very good. So 0.8 to 1 is the specification limit. Fantastic. Super. Anything else? Please type in the chat box. Yeah, bore diameter 133.38 to 133.40. Amazing. Yeah, give the specification. Bottle closure torque limit. Yeah, if you know the numbers, put a number so that people can connect. Cold filling of juice 2 to 4 degrees centigrade. Fantastic, fantastic. 4 to 8. Super, super. So I hope now it is clear. The specification limit, who decides it? The customer decides it. Okay, so ideally specification limits, now, while showing specification limit, we generally show a histogram like this, like normal distribution curve, right? And then we put the specification limits like this. So let's say, for example, this is 70 degree, this is 60 degree, and this is 80 degree. So whatever goes outside of this, meaning any data which goes below 60 degree and any data which goes above 80 degree, we all know it is called as rejection, right? So, and this is lower specification and this is upper specification limit. So generally we use histogram to showcase our specification limit. Okay. Can we show specification limit on the control chart? Can we show the specification limit on the control chart? The answer is absolutely yes. We can do it. And today I will show it as well on the Minitab. Okay. So specification limit, what they show? They show the rejection. Whatever goes beyond specification limit is called as a rejection. Anything which is within the specification limit is called as what? In between the specification limit, whatever product falls. Okay, it's called as what? Type in the chat box. Outside specification is rejection. What is within the specification? Range. No, it is not range. Range is the limit. No? Lower and upper is called range. No, stable is for the control. Stable is for the control chart, not here. You can call it as accepted product or okay product. Yes. See, when the outside is rejected, within is accepted, no? Yes, exactly. And this is also called as, you can just make a note of this, yield. Yield, which is accepted product, is also called as yield, which is within specification limit with customers' acceptance. Outside is rejection, within it is acceptance. So it is also called as yield or accepted product or okay product. Clear, everybody? Specification limit is decided by the customer. We plot it. So that is the topic of the day today. Have you understood this one? So earlier we covered control limits. Now it is specification limit. Have you understood? Now I will plot the differences between these two limits. Okay. Clear hai? Everybody with me? Just type yes. कोई भी doubt नहीं है? Yeah, ask a lot of doubts, huh? Because your doubt clarity is more important. Clearing your doubts is very, very important. Even though it's a fundamental thing, a lot of people would have gone through this session earlier as well. Okay. Super. Application everywhere, na application. So whatever you have mentioned, na specification limits. Okay, specification limits, you have given examples. So all these are specification limits which are used to find out, T का example तो मैंने example आपको explanation के लिए दिया. Okay, that's what whatever examples you have given, na, bore diameter, plus and minus. That plus and minus is LSL and USL. Na? So any bore within that, it will be accepted. Any bore with, which is not within that specification will be rejected. Okay, so these are some of the process capability. This is called process capability. No? Now, so we have just spoke about control limits, upper control and lower control limit. Now we are speaking about specification limits, which is decided by the customer itself. Now, let's find out what are the... All right, let me just plot once again. I will do one one Minitab exercise as well today, just to explain this. let me draw once again our upper and lower control limit. एक बार फिर से निकालता हूं. I'm going back to control limits. Okay, so this is X bar. This is upper control limit. And this is lower control limit. Okay. Now, any variation within this band, write this down. It's called as, anybody knows the answer? You're not able to see my whiteboard, is it? Yeah, is my whiteboard visible? Because I have a couple of screens in front of me and my whiteboard is visible. Okay. Yeah. Shailaji, can you just, if you're on the mobile phone, just switch the screens. Okay, maybe some other screen pe hoga. Huh. So any process variation within the band of control limit, this variation is called as, write this down, common cause variation. And any data which is going beyond this, like these two data points, okay, they are, and as well as this one as well, okay, these are called special cause variation. Very good, exactly, very nice. This is called special cause variation. Make a note of this. Again, this is, I'm drawing a control chart, okay? So any variation within upper and lower control limit, it's called as common cause of variation. And any variation which goes beyond control limit, it's called special cause variation. I always give example of, let's say if you, when you, let's say measure a body temperature, normally it will be a common cause variation. And if you measure body temperature during fever, that will be a special cause variation. Are you understanding the difference? Common cause, see, common causes also, there will be a variation every day. When you are walking, your body temperature will be different. When you are walking in the sun, the temperature will be different. When you are in the air conditioned office, your body temperature will be different. So there will be variation. But when you have a special cause, like let's say viral fever, like I had last week, okay? So that time the body temperature goes up very high. It goes beyond control limit, and that is called a special cause variation. That immediately indicates that there is something wrong in the process. Clear? So special cause variation can immediately be highlighted if you are using the control limits and control charts. Are you clear with this? So you can investigate the special causes and take immediate actions. Clear? It is called special cause variation, and anything within, it's called common cause variation. Just give me yes in the chat box if you have understood this. Another example I can give is your office arrival timing. Okay. Your office arrival timing also, there is always 5 minutes, 10 minutes, 2, 3 minutes, 5 minutes. There will be some variation. That is called common variation. Okay. One day, while driving from your residence to your office, you get a flat tire in the middle of the road, right? And it took you around maybe 45 minutes to 1 hour to change that flat tire. Okay. So you came late to the office, and that is called a special cause variation. It will be highlighted like this. But otherwise, your common traffic and common, what you can say, arrival variation, these are called common cause variation. Yes. Now, let me ask you the question. Or rather, let me give you this very important insight here. Just listen to me very carefully. Okay. special cause variation to identify and to eliminate. Sorry. To identify and to eliminate, you only need, very simple common tools. I repeat again. For special cause variations, okay, to identify and to eliminate special cause variation, we can use simple common senses. But to reduce the variation of common causes, okay, reduce the variation of common causes, we need tools like statistical process control and Six Sigma. How many of you got it? Just type yes in the chat box. Special cause variations are easy to identify. Understand this. Common cause variation reasons are very difficult to identify. For example, when my body temperature was 102, it is very easy now because of my viral fever. When I came late by 1 hour, it is very easy because of my flat tire. It is very easy to identify the reason for it, and we can easily fix it. But if I ask you about this variation, for example, if I ask you about this point, what is the reason between these 2 points? Why there is a variation between these 2 points? You will not be able to identify. Why there is a variation within this band? You will not be able to identify because it requires special investigation. It requires tools like fishbone, viva analysis, hypothesis testing, regression to investigate and to reduce the variation, and that takes extra effort. So you don't need Six Sigma for special causes. You need Six Sigma for common causes reduction. How many of you got it now? Just type yes in the chat box. How many of you got it? Just give me yes. Ha, na. If not understood, please type no in the chat box so that I can explain again. Everybody understood this? Correct? Clear hai? समझ में आ गया? Yeah? Not understood? Yeah, let me explain. Yeah, ऐसे बताओ ना. आप बताएंगे तो मुझे समझ में आएगा. Very good. Anybody not understood? I repeat again. Once again, I repeat, okay? Upper control and lower control, whatever is the variation within this, it's called common cause variation. Why common cause? Because you cannot eliminate it. It will be always there, present, okay? And identifying reason for the common causes is very difficult. Can you give me answer that why have you come 3 minutes late to office? 3 minutes late to office. Why have you come 5 minutes early to office? It's very difficult to give the answer, no specific answer, because it is very small variation. You cannot pinpoint the answer for that. Let's take a case of special cause. When you came 1 hour late, you know the answer that you started late because there was an open house session of your child in the school. So you started late from your residence. There is a special cause associated. You know the reason. Are you understanding? Okay. Common causes, attaching the reason to the common cause variation. This variation, this one, this band is very difficult. This one I'm talking about, this one. If you ask any specific reason why there is a small variation, you will not be able to detect or give the reason for it. But for the special causes, it's very easy to find out. So easy to find out the causes, easy to find out the solution. So special cause variation does not require huge effort. But common cause variation, see, we cannot eliminate common cause variation. But by using statistical process control, by using tools like Six Sigma, we can reduce common cause variations as well. Clear? Variation to reduce, what will the common sense need used? Yeah, so same thing, no? If you have the viral fever, so it is very easy to detect, right? There is a viral fever, so go to doctor, get yourself medicated and cure yourself. If you have flat tire, Either you change it yourself or get a mechanic and change it. So you have a very common, simple, what you can say, solutions for special cause variation. But for the common cause variation, you have to go deeper into the causes, root causes, hypothesis regression, just to make sure it, you cannot eliminate it, but you can reduce it. Clear? Satishji, are you clear with this? Just give me yes in the chat box. Understood somehow? Yeah? Super, super. Amazing, amazing. Now let me ask you another question. Okay, let me just again eliminate this, remove this, and draw this. Okay. Okay. Now, again, I'm just plotting a little bit of sorry. Yeah. This also can be drawn as a horizontal histogram. How many of you got it? Just type yes in the chat box. This is X bar. This is X bar. Have you understood this? The control limits are plotted horizontally, whereas histogram is plotted vertically, but it is actually the same thing. How many of you got it? If I plot it like this, it will look like this. Have you understood this? Control limits are the same data. Control limits, we plot it horizontally. Histogram, we plot it vertically. How many of you got it? और मैं ड्रॉ करके दिखाता हूं. Just type yes in the chat box, okay? Got it, everybody? और एक बार ड्रॉ करके दिखा दो. Just try to understand this. Just try to understand this. Clear your concepts today, okay? For example, process, let's say, is like this. If how many of you got it now? When you have more variation, your histogram will be having a flatter curve. When you have less variation, your histogram will be having a thinner bell-shaped curve. The same plot as is plotted vertically. Yes? Understood? Very good, very good. Super, super. So now let's find out the differentiating factors of specification limit and control limit. Let's plot a. So specification limit and you can just draw a line like this and you have control limit. Okay. Chalo, first of all, specification limits are decided by whom? Type in the chat box. Who decides specification limits? Customer. Very good. Okay. So can I say it is voice of customer? Then who decides the control limits? Everybody? It is the process. Very good. Can I say it is voice of process? VOP. Voice of process is also called as the data from the process. Very simple. Let's make it very simple. Voice of process, nothing but a data. Okay. Now, specification limits. Generally, we use histogram. Generally, we use histogram and control limits. Which tool do we use? Type in the chat box. Which tool do we use when we plot control limits? Control charts. Absolutely right. Control charts. Correct? Yes. Anything within the specification limit, it's called as what? Now listen to very carefully. Anything within specification, within specification limit. Very good, very good. So within, it's called as yield or accepted product. Okay? And outside of it, outside it's called as what? If it goes outside of specification, rejection. Absolutely right. Now, let's go to control chart. Within control limit, it's called as common cause variation. And outside of control limit, special cause variation. Very good, very nice. Special cause variation. Now, with specification limit, we basically check process capability. Capability. Sorry. And with control limits, we check process stability. Stability. Clear, everybody? Differentiation between specification and control limit. Is it clear? Very good. What is the relationship between these two? The answer is ideally there is no relationship as such. There is no statistical or mathematical relationship. Okay? Between specification and control. There is no relationship. But where you would expect control limits, always expect control limits within specification limits. Write this down. Always expect control limits within specification limits. Are you clear? Always expect control limits within your specification limit. That is the ideal situation. Process capability meaning ability of the process. Make a note of this. Just write this down. This is a good question. How do you define process capability and how do you define process stability? Okay. Capability, write this down, write a statement down. Ability of the process to satisfy the customer requirement. It's called capability. Ability of the process to satisfy this requirement of the customer. Requirement of the customer is specification limits. Okay, and what is stability? Ability of the process to remain within control limits. It's called stability. Ability of the process to remain within common cause variation or within control limit. It's called as stability. Clear? So one is showing the stability, other is showing the capability. Yeah, I'll repeat both the statements. Process capability is ability of the process to satisfy customer requirement. Customer requirement in bracket you put specification limit. That's process capability. Coming back to process stability, ability of the process to remain within the control limits. It's called process stability. Now, stability is very important characteristic to improve the predictability of the process. I always give a, um, give example of a very cool, calm child and a notorious child. Okay, बहुत मस्तीखोर बच्चा है, and another one is very stable child. Okay, a stable child, you can absolutely predict that this child will wake up at 6 a.m., gets ready for the school, goes at 6:30, no tantrum, okay, and then comes back at 12, goes to the study on time, goes to the classes on time, completes his homework. It is called a stable process. What is unstable process? Now the child wakes up with tantrum. I don't want to go to school. Next day he will be absolutely happy and he would like to go to school. So there is a lot of behavioral, swings and variations. Okay. It is called unstable, unpredictable. Understand this? So similarly, we always would like to have the process under control and in a stable condition, in a predictable condition. That's why we check the control limits and the stability. Clear, everybody? Just give me yes in the chat box. Let's do a quick exercise here. एक क्विक एक्सरसाइज मिनी टैप का करके देखते हैं हम लोग. सेम डेटा हम लोग लेते हैं. हाँ, इसका ये फाइल ओपन करिएगा, चॉकलेट वाला. आई विल शो यू हाउ यू कैन रेड, येलो एंड ग्रीन जोन. अच्छा, जस्ट अ सेकेंड. All right, so first let's open this file. Let me also open this. All right, so this is the chocolate weight data, our favorite chocolate example. Okay, so we will make our control chart. Okay, open the file and go to stat control charts, variable chart for individual. Just follow this process: stat control chart, variable charts for individual. Done? Everybody with me? Anybody behind, please let me know. See, I have already shown you the sequence: stat, control charts, variable charts for individual. Once you click on that, just double click on chocolate weight. हाँ, no problem, Narsimha. It's very simple. iChart पे जाना है हमको. We need to go to iChart. That's it. Okay. Once you're done, open the file. Let me know. I'll repeat the sequence once again. So once you select chocolate weight here and click on OK, you will get a control chart like this. Yeah, for all the other people who are just behind, just look at this sequence: stat, control chart, variable chart for individual. The same file which I've given in the chat, you can reuse, or you would have that file multiple times. We use the same file for various explanation. Yes? Everybody got this? If you are doing it along with me, okay? If you're traveling, not doing it, it's okay. Just observe this. Got it? Very good. So, what if, can I show here, can I show specification limit on the same control chart? The answer to that is yes, in a way you can show it. I'll tell you how you can do it. Everybody got it? This one? ये simple eye chart है हमारा. Once you click on this individual, you will just select chocolate weight and click on OK. Now, everybody just go to scale. Everybody just focus here. Okay, I'll show it once again. Okay. Stat control chart, variable chart for individual. Select chocolate weight. Now go to scale. Everybody just click on scale. Scale कहाँ पे है? यहाँ पे. Can you see this option called scale? Just go to scale and go to reference line. There are a lot of options like time, axis, grid line, and reference line. Just click on reference lines. And here, show reference lines at Y values. Okay, यहाँ पे आपको, for example, if you want to put lower and upper specification limit, you can put it. For example, I want to put 36 and then a space, which is a gap I have to put, and then 48. So 36 space 48. So 36 is lower specification limit. 48 is upper specification limit. Huh? I'm just trying to show on the control chart. Can I show the specification limit? Okay. So I repeat again, go to scale, go to reference line. Here, I'm just putting 36 space 48. Click on OK and click on OK. Now try to understand this. So this is my X bar. This is my control limit, upper and lower control limit. This is my upper specification limit. And this is my lower specification. How many of you got it? Just type yes in the chat box. Very good. Now see, I can divide this control chart. Now so this is specification limit. This way also you can show it, okay? So always remember this. A good process is that process where your specification limits should always be broader than your control limits. Are you understanding? If your specification limits are narrower than your control limits, it is a bad process. That means more data is going outside of the specification limit. Clear? So your control limit should always be within specification limit. Remember always this. Clear hai? Yes, everybody? Just type yes in the chat box. See, because this part will keep on floating. ये जो part है ना, this specification limit will be stable. Control limits will keep on changing according to the process behavior. So our role is to control the process variation and bring it to the center as much as possible. That is our target. Clear? Yeah. So see, understand this. Apart from that, there are, for example, this is 1 sigma. If you remember, I mentioned about this 3 sigma, right? UCL का formula क्या है? X bar plus 3 ना? Okay. So let's say this is 1 sigma. This is 2 sigma. and this is 3 sigma. Okay. And similarly, X bar minus also, this is minus 1 sigma. Then this is minus 2 sigma. And this is minus 3 sigma. So X bar plus 3 and X bar minus 3. This way, these bands also can be created. Okay. And some people show it in a zones as well. Like who mentioned that the zones red, yellow, and green, etc. So again, it depends on some softwares also nowadays show. Okay, the central band is of green. The band which is between around 2 sigma is around yellow, and the band which is going very close to the control limit is a red zone, which is you are going very close to the danger zone, control limit के बाहर जाने वाला है. So always remain in the band of green and yellow. That's what it means basically. Yeah, clear everybody? Just give me yes in the chat box. Understood today? Control limit and specification limit, the difference. What if all the data points are within specification and upper control is more than upper specification limit? It's a bad process, no? Upper control is more than upper specification limit. That means you are losing lot of data points on the higher side, right? So it's a bad process. You immediately have to bring down the process to the center and stabilize it. Okay, that's how you need to do Pawanji, because any data going beyond specification limit means a rejection. We all know that, right? So if your upper control is going beyond specification limit, that is an indicator that your process is shifted on the upper side. So you have to identify the reasons and bring the process back to the center. Okay, super. Yes, thank you very much for patiently listening. I hope it has given you some insights about this confusing control and specification limit. Yes, yeah, was it useful and interesting? मजा आ रहा है सीखने के लिए?
बिल्कुल सर, बिल्कुल सर.
Yeah, thank you very much. Thank you very much. Thank you. And thank you very much, being on Monday and busy day. आप लोग travel करके भी ये live session. A lot of people are driving and listening to this session. I feel so proud and so thrilled. You guys are so committed for learning. I really appreciate and really hats off to your commitment. Okay, I wish you all the very best. We'll connect again with a new topic next week. Next week. Yeah, next week itself. We will have the hackathon. We'll give all the details about it next week itself. Saturday भी हम लोग connect करेंगे with a new topic. Saturday generally we cover a little deeper topic. Okay. Of course Saturday also will be there. We'll connect a deeper topic on this. All right. And most probably some the people who have upgraded for the business launch program. Okay. For them also, we are planning a session this week. Okay, so that them also will get the notification. All right, super. Is there any forecast for session before 3 to 4 days? Forecast, see, our days are absolutely other topic we are talking about. Okay. Acha, see, topic, what happens is a lot of people suggest or ask the question or suggest for the topic. So those topics are taken in the, because see, why don't we take the sequence? Because everybody journey starts at different points. Okay. So somebody at a define phase, somebody is studying control phase, somebody is in analyze phase. So orchestrating everything is a little challenge. So generally we cover a little confusing, a little tough to understand topics in the live session. Okay, all the topics you will not see me taking the project charter or SciPoc in the live sessions. Okay, because I want live sessions to be like this. Okay, a little deeper conceptual understanding, practical understanding like that. Okay. Hackathon, new joiners also can join the hackathon sessions. Yeah. Okay, you can join. Absolutely, you can join. Even black belt also you can join the hackathon. It's amazing experience. Because anyway we are signed up for green and black belt both, right? So आज नहीं तो कल आपको ब्लैक बेल्ट भी सीखना ही है, आपको डिजाइन ऑफ एक्सपेरिमेंट सीखना है, एडवांस हाइपोथेसिस सीखना है. If you are ready to absorb that advanced topics, okay, then you definitely come. Okay, yeah. Thank you very much for joining. So keep learning, keep growing. We'll connect again with a new topic with the same enthusiasm. Till the time, keep learning. Bye bye. Take care. Good night.